Now we are going to discussing about the chemistry of carbon compounds, and simply it is also called as carbon compounds. Chemistry of carbon compounds. Clear? Chemistry of carbon compounds. Clear? Now you can see here the chemistry of carbon compounds is also simply called as organic chemistry, right? Now we are going to discussing about some introduction part about the carbon compound. Now we know that the first carbon compound synthesized in the laboratory, the first carbon compound synthesized in the laboratory, that is urea. Clear? So by Wohler scientist, by Wohler scientist in 1828. So that compound having the molecular formula as NH2CO NH2. So you can observe the structure also here, NH2CO NH2. Clear? And this is can be synthesized by using the decomposition, thermal decomposition, nothing but simply upon heating ammonium cyanide. Ammonium cyanide, the molecular formula is NH4NCO. Ammonium cyanide. Clear? Now this ammonium cyanide, upon heating we have got a urea, and this is completely synthesized by using the inorganic source, by using the completely inorganic source. Clear? So not only that, urea and other compounds also can be synthesized from the inorganic sources. In 1845, Kolbe, scientist name Kolbe, introduced acetic acid, synthesized acetic acid. Similarly, Berthelot scientist in 1856 synthesized methane gas from the inorganic sources. Clear? Now we will discuss about the organic compounds. Clear? Now these organic compounds, nothing but these are compounds of carbon and hydrogen and other derivatives. And just now I have explained what is meant by organic chemistry, right? It is the study of chemistry of carbon compounds. Simply it is called study of chemistry of carbon compounds. Clear? So why the necessity to study the carbon compounds? Why only the carbon compounds? Why not other silicon compounds? Why not boron compounds? So comparatively other elements, carbon have some unique properties. That is, one is tetravalency, another one is catenation. So here we know that already tetravalency is nothing but here we are having 4 valence shell electrons in the carbon atom. We know that carbon atom atomic number is 6 and configuration is 1s2, 2s2, 2p2, and valence shell containing 4 electrons. Clear? Upon excited state we have the configuration that is 2s1, 2p3. Right? So here one electron present in s orbital and 3 unpaired electrons are present in p orbitals. Clear? And hence due to the presence of these 4 unpaired electrons in one s orbital and 3 p orbital. Clear? One s orbital unpaired electron, 3 unpaired electrons present in the p orbital. So by utilizing this tetravalency, carbon can form large number of compounds due to the catenation. So what is meant by catenation, sir? Catenation is nothing but it is having a tendency to form long chains with itself or with other elements. That means carbon can form like this, longest chain, long chain. Clear? So carbon can form not only with the carbon, it also can form long chains with other elements. Clear? So because of that, the tendency of chain formation of carbon is known as catenation. So because of that catenation, it can form multiple bonds also in between two carbon atoms. Multiple bond means more than one bond. Here double bond you can observe, here triple bond you can observe, right? So like that, a carbon can having tendency to formation of chain as well as multiple bond formation ability. So due to that, we will get more number of carbon compounds. So why not other elements form more number of compounds like carbon which present in the same group? That means, example, if you observe 14th group elements, carbon group elements, you can observe here carbon, silicon, germanium, tin and lead. So if the carbon having tetravalency and other elements also having tetravalency, but why not other elements cannot form like carbon multiple bond ability or longest chain tendency formation? Because from top to bottom, bond energy decreases because of the electronegativity decreasing. So even though other elements also having 4 valence electrons, but there is a less electronegativity in these elements. So because of the high electronegative and small atomic size, tetravalency, catenation capacity. So due to these reasons, carbon can form multiple bonds as well as longest chains with the carbon and with other elements. Clear? Now you can see that tendency chain formation with itself or with the other elements. You can see here. So here organic compounds, nothing but carbon compounds, also possess with nitrogen, or carbon compound maybe contain oxygen or halogen, phosphorus, sulfur. Right, halogen means we know that fluorine, chlorine, bromine and iodine, any 17th group element. Clear? So like that, these elements necessary for an organic compounds, right? So carbon, not only with carbon, it also combined with hydrogen, it also combined with nitrogen, oxygen, sulfur, phosphorus, any halogen. So to tendency of formation of multiple bonds or tendency of chain formation with itself and with other elements. Clear? So bonding, due to that bonding with the carbon itself or with other elements, there is a formation of covalent bond, right? Because of the sharing of electrons, because of the overlapping of atomic orbitals, right? Now because of the overlapping of atomic orbitals, we know that there are two types of covalent bonds. One is sigma bond, another one is pi bond, right? So depending upon that number of sigma bonds and pi bonds, we can calculate the carbon, we can calculate the carbon hybridization. We can calculate the carbon hybridization depending upon the covalent bonds. So now here we have given a simple shortcut formula to identify the hybridization of carbon in compounds. Like example, here I have given a carbon compound, that is methane. So in methane molecule, around the carbon there is no pi bond. There is no pi bond, that means zero pi bonds. You can observe here, we know that types of covalent bonds are two types. One is sigma bond, another one is pi bond. So therefore around the carbon atom there is no pi bond, so therefore zero pi bonds are present. So therefore at that time we can write the hybridization as sp3. Clear? Suppose if we are having a pi bond between the two carbon atoms, example I am giving here ethene, example here I am giving ethene. So around the carbon atom, you can observe here around this carbon atom, one pi bond will be there. So therefore, if one pi bond is present, that carbon undergo sp2 hybridization. Clear? Similarly, here one more carbon atom also present. So that carbon atom, that carbon atom also having surrounded by one pi bond. Therefore, it also undergo sp2 hybridization. Similarly, here I am giving one more example. You can observe that is ethine. That is ethine. Clear. So in ethyl molecule, the carbon atoms are surrounded by one sigma bond. Sorry, one pi bond. Here, one pi bond here. So therefore, total two pi bonds will be there. So if two pi bonds are there, the hybridization will become sp. So here in ethyl molecule, both the carbon atoms are surrounded by two pi bonds. So therefore, each carbon undergo sp hybridization. So there are so many tricks to identify the hybridization. Few people will consider sigma bonds. Right here we have given pi bonds in terms of pi bonds. So you may calculate in terms of pi bond or sigma bond. In some other uh, books they also given as like number of sigma bonds around the carbon atoms, that also represent here 4. So therefore, when according to the overlapping of atomic orbitals 4, here we have given based on the overlapping. Here two formation of 4 covalent bonds, 1 s orbital and 3 p orbitals are involved. So like that also you can calculate. So according to the sigma bond, if you observe 4 sigma bond around the carbon atoms, that hybridization will be sp3. If you observe the carbon atoms surrounded by the 3 sigma bonds, then hybridization will be sp2. If you observe the surrounded by the carbon atom with the 2 sigma bonds, and hence it is sp hybridization. So you may calculate with in terms of sigma bonds or pi bonds. That is your choice. Clear? Now, next, depending upon the carbon surrounding bonds, we have defined the hybridization of that carbon. Clear? Next, we are going to discussing about the representation of organic molecules. Representation will be divided into two types. One is in terms of molecular formula, another one is in terms of structural representation. Molecular formula, another one is structural representation. What is meant by molecular formula? Suppose examples, till now I have given few examples for you, like a methane, ethane, propane. So whatever the molecule will be there, that molecule we can indicate in terms of total number of atoms present in that compound, as like a C3H8, CH4, C2H6, C4H10, right? So these can called molecular formulas of the compound. And the second one is structural formula. This structural representation will be divided into three types. We can write as like complete formula or condensed formula or bond line formula. Clear? So overallly, this all represents that exact number of different type of atoms present in a molecule. That is called simply molecular formula. That molecular formula we can represent of organic compound. Clear? So molecular formula is nothing but the total exact number of different type of atoms present in the given compound. So that compound also we can indicate in terms of three modules, like three ways, like complete, another one is condensed, and last one is bond line formula. So what are these three? You can observe here one by one. So structural representation, like example C2H6, C2H4, C3H8, C3H6. Here I have given some molecules, and these molecules completely expanded. Here each and every bond is represented between the atoms, right? Each and every bond are represented between the carbon atoms. Clear? And hence this is called expanded formula, complete formula or expanded formula. Clear? If we indicate each and every bond present between the two atoms is called expanded formula. Clear? Complete structural formula. And the second one is condensed formula. Second one is condensed formula. Clear? What is meant by condensed formula? Condensed formula is nothing but here we can simply indicate the only number of atoms present in the given compound. Suppose example here I have given CH3, CH2, CH2, CH3. Clear. So this we can write without a bond. Simply remove the bond and put together. Clear. So I have removed that bond and all these are put together. Clear. CS3, CS2, CS2, CS3. And this is also we can condense. Nothing but we are writing in a short way. That is called condensed formula. Now here we have, if you observe here, CH2 two times will be there. So here I have once again condensed this formula as CH3, CH2 taken twice, CH3. Clear. So simply without a bond, whatever the number of atoms, number of groups will be there that added together. Clear. That you can write by putting together. Clear. Now one more important, that is bond line formula. What is meant by bond line formula? So here there are no atoms. Simply in these representations the atoms are not shown. Clear. And simply the carbon carbon bonds you can observe in zigzag fashion. Clear. So when apart from the carbon atoms are present, that can be specifically written as like if it is OH is present or NH2 is present or some chlorine is present in that given carbon compound. So like that we can write bond line formulas. So simply there are no carbon atoms, there are no hydrogen atoms, but apart from the hydrogen and carbon, if there is any oxygen and a nitrogen functional groups, right, substituents is present, that we can indicate. Clear. Suppose example here butane I have written like this, right, like a zigzag mode. Here one chlorine atom is there, right, here one more branch is also there. So simply we can write like this in zigzag mode. Clear. So this is what called bond line formula. Here there are no indication of the carbon and hydrogen. Specifically if it is there in other atom, that we can write with respective to functional group or substituents if it is present. Clear. Now next come to the 3D representation of organic molecules. 3D representation. So this 3D representation of the organic compounds is given with reference to the one methane molecule. Clear. So in this 3D representation we can use dashes, wedges and straight line. So what are these dashes, wedges and straight line? Suppose whatever the carbon tetravalency is there in terms of three-dimensional geometry, two atoms are present in the same plane. Two atoms are present in the same plane, and one will be the out of the plane, another one will be the inside of the plane. So therefore these out of the plane or inside of the plane, that is given based on the observer, based on the observer. So the observer given some representations as wedge and a dash, which is very close to the observer, is known as wedge, which is very far away from the observer, and hence it is denoted by dash. So these symbols can be represented the dash, right, nothing but away from the observer. So if you are observing from here, it will be very close to the observer, it is away from the observer. Which is away from the observer, that is denoted by dash, and which is close to the observer, which is known as wedge. So wedge can be indicated like this, and these two atoms are present in the plane of the paper. Clear. Now we can see the classification. The original organic chemistry is now going to be started. So in classification of organic compounds, there are so many types are present. So first of all, you have to know how many types of carbon compounds will be there basically. So basically these are divided into two types. One is open chain compounds, another one is closed chain compounds. So as per the terminology, that is, one is acyclic, another one is cyclic. Clear? Now this cyclic compounds once again divided into two types: alicyclic, aromatic. Clear? Sorry, here I have indicated reversely, and I can rectify that easily. You can see here, one is I have given in reverse order. You can check it. Here it is acyclic, means it is not closed. That means here it is open chain, and here it is cyclic. That means it is closed chain. So the carbon atoms which are bonding together in an open chain form, and hence it is called acyclic. Means it is not cyclic. Acyclic means it is not cyclic. It is open. Right. Now another one is a cyclic. That means it is not open. It is closed. The carbon atoms are arranged in a closed format. Clear? So now these open chain compounds are divided into two types. Right. One is straight chain. Another one is branched chain. Acyclic compounds are divided into straight chain. Another one is branched chain. Similarly, here you can observe that cyclic compounds are divided into two types: alicyclic, another one is aromatic. We will discuss one by one in complete detail. Clear? So once again, alicyclic divided into homocyclic, another one is heterocyclic. Right? So what are these homocyclic, heterocyclic? With each and every type of carbon compounds we will discuss with suitable examples. Clear? So once again, heterocyclics. Hetero means different. In a carbon chain, in a closed carbon chain, there are other than carbon atoms also present, and hence it is called heterocyclic. And what is meant by homocyclic? It is a cyclic compound. It contains only same kind of atoms, that is carbon. Clear? So like that, heterocyclics once again divided into two types, that is benzenoid, non-benzenoid. What are benzenoids, sir? You can observe in the title only. The compounds must be contained with one benzene ring is called benzenoid. Clear? And which does not contain benzene, those are called non-benzenoids. Clear? So once again we will discuss one by one with a complete detail. So here once again, the part 1 we are rating acyclic, means it is not cyclic, that means it is open. It is cyclic, that means it is closed. Clear? Now examples you can see here. Here a carbon compound is there. We have indicated in terms of bond line. You can indicate like this, you can indicate like this, you can indicate like this, right? So these are open chain compounds. You can indicate like this, you can indicate right like this. So these all are comes under the open chain carbon compounds, nothing but here it is not closed. Right. Now cyclic compounds, nothing but closed chain. You can observe here closed. The carbon atoms are arranged in a closed format. Clear? You can observe here and here. So these acyclic and cyclic compounds, once again, already we have discussed, but here we are in detailedly going. Right. So acyclic, you can observe here it is two types: straight chain, branched chain. So straight chain you can observe here CH3, CH2, CH3, right? CH3, CH2, CH3. There is no branch, but when you observe here, there are two branches. Clear? So in this carbon compound, you can observe here two branches. So this is the main chain, and these are called branches. Clear? Now, alicyclic. Alicyclic is the part of cyclic compound. Cyclic compounds are divided into two types. One is alicyclic, another one is aromatic. Alicyclic means these cyclic compounds which can exhibit the similar properties like aliphatic. So these are having similar property with the aliphatic carbon compounds. Like example, here it is cyclopropane. It is closed, but it is a cyclic compound, but its properties are completely similar with the acyclic compounds. Clear? Now, aromatic compounds. Aromatic compounds. Example, here I have given benzene. So here it says separate topic will be there to identify aromatic nature. Clear. So it is a complete depth level information we will give in the next sessions. So here it is aromatic. Nothing but aroma is nothing but a good smell, a pleasant smell. The carbon compounds which is having a pleasant smell are called aromatic. And this is also you can observe based on the experimentally which gives a sooty flame. So upon heating, these carbon compounds can give sooty flame, and hence these are called aromatic. If it is not sooty flame, and hence it is called alicyclic. Clear? Now once again here we are discussing about alicyclic. Just now I have used another term aliphatic. Both are same. Alright. So alicyclic are once again divided into two types, homocyclic and heterocyclic. Just now I have explained homocyclic. Cyclic is nothing but carbon compounds are carbon are arranged in a closed format, right, with the same kind of atoms. Here all are carbon atoms, right? Carbon is linked with the carbon only. One type of atoms are present with the carbon in the cyclic compound. When it comes to heterocyclic, carbon is linked with the other than carbon. Like example, here carbon is attached with the sulfur in the closed format. Clear? So therefore, it is called heterocyclic compound. Heterocyclic compound is nothing but the carbon compounds contains like sulfur, nitrogen, oxygen or halogens. Clear? Phosphorus, whatever, other than carbon. Not only carbon, in that compounds other than carbon also will be present. Those type of compounds are called as heterocyclic. Clear? Heterocyclic. Next we are going to discussing the aromatic compounds. So as already we have seen, aromatic compounds are divided into three types. Aromatic are divided into three types. One is benzenoid, another one is non-benzenoid, another one is heterocyclic aromatic. It is aromatic as well as heterocyclic. That means once again we will discuss one by one. Benzenoid, I told you, which contains at least one benzene ring. At least one benzene ring. Hence it is called benzenoid. You can observe here one benzene ring is attached with this cyclic compound. Clear? So therefore it is called benzenoid. Clear? You can observe that naphthalene also is an example of benzenoid. Right, naphthalene. Here I am writing the structure. Right, here it is naphthalene. This is the naphthalene structure. It is the one previous question they have asked about the naphthalene. The total number of sigma bonds and pi bonds are present in the naphthalene molecule. Clear? So you can calculate how many sigma bonds and pi bonds are present in the naphthalene. Clear? So here naphthalene contain one benzene ring. You can observe here one benzene ring. So therefore it is a benzenoid. Clear? Now come to the non-benzenoid. What is meant by non-benzenoid? Non-benzenoid is nothing but the carbon compounds does not contain a benzene ring. Is called benzenoid and it is in a cyclic format. It is in a cyclic compound. It is a cyclic and it is aromatic. So how do we identify aromatic? We will discuss in next sessions, right? So non-benzenoid is also aromatic, but it does not contain a benzene ring. Like that, it contains aromatic nature, Clear. But apart from the carbon atoms, it consisting other atoms like nitrogen, oxygen, sulfur. Clear. These type of compounds are called heterocyclic. Clear. Next one, beta, we are discussing about the hydrocarbons. What are hydrocarbons, sir? Simply the compounds which contains only carbon and hydrogen are called hydrocarbons. So these hydrocarbons are divided into two types. One is saturated, another one is unsaturated. One is saturated, another one is unsaturated. We know that examples of saturated hydrocarbons are alkanes. About unsaturated, alkenes and alkynes. Clear. Now we will discuss one by one here what are saturated and what are unsaturated. Saturated hydrocarbons are nothing but in between two carbon atoms. You can observe here in between two carbon atoms there is only one bond is present. You can observe here in between two carbon atoms only one bond. Here you can observe in between these two carbon atoms only one bond. Like that here between two carbon atoms if it consisting only one bond and hence it is called saturated hydrocarbon. Clear. If each carbon atom is joined to four other atoms according to the tetravalency, and that must be, you can observe with respective to carbon or hydrogen, it has no potential to form more bonds and it is therefore saturated. Simply you can also write which contains only single bond between the two carbon atoms is called saturated. If it is having ability to form a double bond and triple bond, obviously carbon having multiple bond ability formation, right? So if it consisting double bond or triple bond, then it is called unsaturation. Clear. In between two carbon atoms if it is having more than one bond, hence it is called unsaturation. And next term we are going to discussing about the functional group. What is meant by functional group? Functional group is nothing but which decides the physical and chemical property of the carbon compound. Functional group which decides the physical and chemical property of that carbon compound. Suppose example I have taken a carbon compound like this. Here it is having some functional group which is called alcohol. So now that whole carbon compound property can be decided by the OH which is called functional group. Clear. So here functional group is nothing but which decides the physical and chemical property of the compound. Here I have given one more example. So in this carbon compound it contains COOH. So this is called functional group which decides the physical and chemical property. Clear. Now next we are going to discussing about the differences. Any carbon compound which contains functional group or without functional group, whatever you may take. Suppose example I'm taking methane and ethane, propane, right? I have taken some examples here. Ethene, right? Propane, whatever, with functional group or without functional group. If a series of carbon compounds in there if having CH2 difference, that means if you observe methane and ethane, there is one carbon and two hydrogen atoms are difference. If you take ethane and propane, you can observe here in these two, one carbon and two hydrogen atoms are difference, right? So if it consisting a CH2 difference, those are called homologous series. Clear. So here I have given complete definition about the homologous series. Clear. So in that homologous series they have same chemical properties, A series of similarly constituted compounds which the members possess the same functional group, have same chemical properties, have a regular gradation in their physical properties. In successive homologous series differed by CH2. Suppose here I will give like this CH3COOH. Next I have given CH3CH2COOH. So here these two compounds are differed by the CH2. So at that time there is a similarity in the chemical properties and have a regular gradation in their physical properties. And these two are called homologous pair. So the carbon compounds which can have differ with the CH2, which can have differed with the one carbon and two hydrogen, are called homologous pair or homologous series. Clear? Like ethane, propane, alkanes, alkynes, whatever the carbon compounds will have, which the differed by the CH2, then hence it is called homologous. Clear? So identify homologous pair means what you have to check. There must be, in that pair must be one carbon and two hydrogens have difference. Clear? Now, next, by using the carbon compounds, now we are going to giving the names. Right? So here we have two types of names. One is common name, another one is IUPAC name. Clear? So what is meant by common name? Common names are assigned based on their origin, based on their origin or based on their certain properties. Right? Like example, formic acid is the common name of HCOOH. Formic acid is the common name of HCOOH. Right? So why it is called formic acid? Because this chemical is released from the red ants, and these red ants in Greek language it is called formi, and hence it is called formic acid. Clear? Formic acid. Similarly, citric acid, which is obtained from the citrus fruits. So based on the source or based on the scientist name, right, based on the origin, they have given some names, they have assigned some names, and those names are called common names. Like example, acetic acid is the common name of ethanoic acid. Clear? And second type of nomenclature is IUPAC. Second type of name. One is based on the origin, based on the source, right, where it is occurred. Based on that, we have assigned some names which are called common names. Clear? We have seen one example for that, formic acid, right? Like acetic acid, citrus fruits, citric acids, right? So next, beta, based on some rules given by the union, that is International Union of Pure and Applied Chemistry, simply denoted by IUPAC. So they have given some set of rules to give the name of the carbon compound. So by following that rules, we have to give the names for that carbon compounds. So as per the IUPAC, once again I'm repeating here, IUPAC is nothing but International Union of Pure and Applied Chemistry. Clear? So here we have given with some elements, right? So I for iodine, U for uranium, P for phosphorus, AC for actinium. So here we have given some interesting IUPAC. Clear? Now this IUPAC nomenclature follows a basic general formula, that is consisting some variables which consisting word root or root word, that is your choice. You can call it as word root or root word, and after the root word whatever we are using, which is called suffix, and before the root word whatever we are using, that is called prefix. So here prefix plus root word plus suffix. So what are root words? What it describe us? What is meant by suffix? What is meant by prefix? What it actually gives the information, we'll discuss one by one. Clear? So first of all, root word. What is meant by root word? It describe about the number of carbon atoms. It describe about the number of carbon atoms. So if it contains in the given carbon compound, if one carbon is present, then that root word will be meth. And if two carbons are present, that root word we can write it as eth. Like that, prop, if it is contained three carbon atoms. So like that, here I will explain one by one. You can observe here, if in the given carbon compound, in the main chain, if it consisting one carbon, we will write the root word as meth. If it is two, and we can write it as eth, like 3 prop, 4 but, 5 pent, 6 hex, like that you can see here. Clear? Based on the number of carbon atoms, we will use a different kind of root words. Clear? So where root word describes about the number of carbon atoms. Clear? So depending upon the number of carbon atoms, we will use the different type of root words to give the names of those carbon compounds. Clear? Once again, you can here observe one more term, that is suffix. What is meant by suffix, sir? Suffix is nothing but which comes after a root word. Whatever the thing we are going to writing after the root word is called suffix. So this suffix divided into two types. Suffix is divided into two types. One is primary suffix, another one is secondary suffix. Now here I have given primary suffix. What it actually tells about the carbon compound. So this primary suffix can describe about the nature of bonding. About the nature of bonding. What it describe? It describes about the nature of bonding. That means if a carbon bonded with a single bond, hence for this type of compounds we will write the primary suffix as "ane." Clear? If the carbon atoms are attached with a more than one bond, like double bond, then primary suffix we can write it as "ene." Similarly, if it is contains triple bond between two carbon atoms, then we can write the primary suffix as "I." Clear? Y-N-E-I. So these in, I are common primary suffixes. Clear? So depending upon the saturation and unsaturation, I hope that you are clear with the single bond, double bond, triple bond, right? So depending upon the saturation, unsaturation, we will write the in, I as primary suffixes, which is indicate the nature of bonding. Clear? Now, next here one more also will be there, sir. If a carbon compound contains both double bond and triple bond, simple, we can write it is both in and I by putting together. So therefore, that is commonly called it as alkene. Clear? If it is contain both, then we will write it as in ion. Clear? So in 9, it is called in ion. Clear? Now, next, we are giving the naming for saturated hydrocarbons. Examples: alkanes. We know that general formula. These are hydrocarbons, right? Alkanes are hydrocarbons. That means it have only carbon and hydrogen. So general formula, you know that is CnH2n plus 2, right? General formula CnH2n plus 2. So like that, here we have given one example, butane. Or you can go to directly based on the structural formula, structural compound. So here I have given a structure of the carbon compound, CH3 CH2, CH2, CH3. Now what is the name of this organic compound? Now first we have to see the root word. Here specially we are discussing only saturated hydrocarbons. Clear? So for that I have given only single bonded carbon compounds. So now first I am observing root word. That root word is 4 carbons. So therefore here it is but. And next after the root word, that is suffix. Suffix is divided into two types. One is primary suffix and secondary suffix. Now I have to observe primary suffix. So in this carbon compound, primary suffix nothing but single bond. Nature of bonding, observe the nature of bonding. Clear? So therefore it is single bond. So I am writing primary suffix as "-ane". Clear? What about secondary suffix, sir? What about secondary suffix? Here there is no secondary suffix. So how do we identify? Secondary suffix is nothing but it is describe about the functional group. It is describe about the chemical property, physical property, nothing but functional group. So here there is no functional group, right? And one more important, just I have given only naming of saturated hydrocarbons. So here you can ignore this secondary suffix because there is no functional group. Clear? Even we will discuss completely what is secondary suffix, what kind of functional groups will be there, right? Now, next one, you can observe here I have given one more compound. In this carbon compound, you can observe here some double bond is present, right? So in this carbon compound, you can observe the 3 carbon atoms. So therefore I have given root word as prop. And the nature of bonding, you can observe here double bond. So therefore for the double bond, I have used primary suffix "-ane". So therefore it is propane. Clear? Now similarly, I have used one more carbon compound here, which consists in triple bond. Clear? And the root word is 3 carbon. Therefore it is prop. And it consists in triple bond. Hence I have used "-ine". Clear? So this is what propane. And when it comes to secondary suffix, I will explain about the secondary suffix. What is meant by secondary suffix? You can observe here secondary suffix. What is meant by secondary suffix? So secondary suffix describe about the chemical property. What it gives the information to us, it describe about the chemical property. Chemical property. So therefore this chemical property depends upon the functional group. Depends upon the functional group. So here I have given some functional groups. You can observe here. Those functional groups. Here I have given some functional groups. Example, you can see here the functional groups ether. Ether. Clear. I have given some functional groups ethers. Carboxylic acids. You can see here carboxylic acid. Right. So if any carbon compound contain carboxylic acid like COOH, formula will be COOH, and we can use the secondary suffix as oic acid. We can write the secondary suffix as oic acid. No need to write complete carboxylic acid. Simply there is a shortcut they have given for every functional group. So for carboxylic acid, if any carbon compound it contains, like example here you can observe, it is containing C double bond OH, right? COOH, and hence you can use the secondary suffix. You can observe here root carbon, root word, that is 2 carbons, hence it is eth. And nature of bonding, nothing but primary suffix. This functional group carbon is bonded with a single bond. So therefore "-ane", you can observe, I will write once again, root word is eth and the nature of bonding is "-ane, and functional group, that functional group is COOH. So therefore secondary suffix we can use as oic acid. So therefore oic acid, carboxylic acid na? So therefore no need to write complete name, we will use some short names as oic acid, and hence we will put together all these, during in the process E will be get eliminated. We know that according to the English grammaticals, A, E, I, O, U cannot be adjacent to each other. So therefore E will be get eliminated, and hence it is called ethanoic acid. Right? Now you can observe here also. Here root word is 3 carbons. So therefore I have used prop root word. Then primary suffix. And in this carbon compound having functional group, this functional group carbon is bonded with the single bond. So therefore ane. And a secondary suffix is oic acid. So therefore it is called propanoic acid. So like that, for each and every functional group there is a secondary suffix. There is a short symbol which represents that functional group. Those are called secondary suffix. So like alcohol, if it is alcohol functional group present, then we will write the secondary suffix as ol. If it is aldehyde functional group is present, then we will write it as all, all. Alcohol, last 2 letters ol. Aldehyde, first 2 letters all. Right? Carboxylic acids, just now I have explained. We will use the secondary suffix as oic acid. We will use the ester. For ester, we will use the secondary suffix as oate. Clear? Like that, here for sulfonic acids, we will use that sulfonic acid. Right? You can observe here acid anhydride. Formula COO, COR. You can also write like this: C double bond O, O C double bond O, R. Right? So for this functional group, we will write it as oic anhydride. Oic anhydride. Like that, there are so many functional groups will be there. Just now I have explained ester. Functional group is COOR. For that secondary suffix, we will use as OA. Clear? So here like that, acid halides. Example, C double bond O X. There are so many functional groups will be there. Acid halides for this type of compounds. If any carbon compound contains, for any carbon compound contains C double bond O X, we know that where X is fluorine, chlorine, bromine, iodine. You can observe here one uh, example also. So here this is what C double bond OCl. It is attached with a hydrogen, right? So in this carbon compound having only one carbon, that means root word we have to use meth. And you can observe here this carbon is bonded with chlorine and hydrogen, right? Here it is carbon. This is what completely functional group, right? So here carbon hydrogen having single bond, therefore ane. This is primary suffix, and secondary suffix is oil halide, OYL, right? So therefore OYL halide, here halogen is used chlorine, so therefore we will write as chloride. So methanol chloride, methanol chloride. Like here 2 carbons are there with C double bond OCl, so therefore it is called ethanol chloride. So like that, here we have many functional groups. Like example for amides. For amides, we can use simply amide only. Like that, amines functional group. Like that, amines cyanides. Right. For cyanide functional group, we will use the secondary suffix as nitrile. We can use the secondary suffix as nitrile. Clear? For isocyanates, nothing but which contains NC. You can observe the structure also N triple bond C, right? So for this compound, you have to use the secondary suffix as isonitrile. For CN, nitrile. Clear? For NC, isonitrile. For NC, we will use isonitrile. Like for aldehyde, already I have explained first 2 letters, all. For ketones, CO, you can write simply CO, or you can write like this, C double bond O. Clear. For these ketones last three letters is the secondary suffix. Clear. So like that, many functional groups. One more I have given in the initial only. Alcohol, last two letters. Alcohols. Functional group is OH. Similarly, thiol, you can observe instead of oxygen here sulfur is present. So if it is in OH in place of oxygen, if sulfur is present, then it is called thiol. So therefore suffix, secondary suffix, we will use it as thiols. Clear. So these are different type of functional groups which we can use. Depending upon the functional group, we can use the secondary suffix. Clear. So still now we have discussed root word, primary suffix, secondary suffix. Clear. So now once again I'm repeating, primary suffix describe about the nature of bonding. Either it is attached with single bond or carbon atoms are attached with double bond or triple bond. If it is attached with a single bond, we will write it as in. If it is double bond, we can write it as in. If it is triple bond, in. Now, secondary suffix describe about the chemical property, which depends upon the functional group. So there are so many functional groups, right? For this, you can go through the NCERT chart, functional groups. So accordingly, the functional groups, different type of secondary suffix can be used. Clear? Right. Next, we are going to discussing about the prefix. So already we have seen root word plus primary suffix plus secondary suffix. Suffix nothing but which comes after root word. These are two types, primary and secondary. Once again, before the root word, whatever you are using, that is called prefix. Clear. So this prefix once again divided into two types. One is primary prefix, another one is secondary prefix. Clear. So therefore overall formula I am writing primary prefix plus secondary prefix. Clear. Plus root word plus primary suffix plus secondary suffix. Clear. So this is what a whole general formula to write the name of the carbon compound. Clear. Apart from this, there are so many rules will be there. So we will discuss one by one. Clear. So now here primary prefix. We are going to discussing about the primary prefix. So already I told you prefix is nothing but which comes before the root word. So now we are going to discussing about the primary prefix. So primary prefix, it is only used for cyclic compounds, which is only used for cyclic compounds. It is not for open chain compounds, only for closed chain compounds. For those type of closed chain compounds, we will use the word cyclo as primary prefix. Cyclo as primary prefix. Clear? So once again I'm repeating, it is applicable only for closed chain compounds. The term cyclo can be used as primary prefix. Example, you can observe here example. I have given a closed chain compound. Here you can observe, clear, you can observe here, I have given a closed chain compound. Now as per the rule, first observe the root word. Root word contains 1, 2, 3, 4, 5 carbons. So therefore I have used the root word pent plus primary suffix. Means these carbon compounds are surrounded by only sigma bonds. You can observe here. Clear, only sigma bond, these carbon compounds. Therefore I have used the primary suffix as "-an". And is there any secondary suffix? There is no secondary suffix. Why? Is there any functional group? No alcohol, no aldehyde, no ketone, no carboxylic acid, no ester, no amine, no amide. So therefore secondary suffix is ignored. So next come to this compound. Is this compound is open chain or closed chain? So closed chain. So therefore we have to use primary prefix. So for cyclic compounds we have to use cyclo. So therefore hence the name of the compound is cyclopentane. Cyclopentane. You can observe the next name of the carbon compound. What is the name of the compound? Right. Absolutely. Which is called cyclohexane. hexane. Why? Because it is closed chain. So I have used prefix cyclo, right? And the root word is 6 carbons. You can observe 1, 2, 3, 4, 5, 6 carbons. And nature of bonding is single bond. So therefore cyclohexane. Now name of this compound, cyclopropane. Name of this closed chain compound, this is cyclobutane. Clear? So this is cyclopentane, this is cyclohexane. So next we will observe about the secondary prefix. We can observe about the right. Now you can observe the secondary prefix. What is meant by secondary prefix? Secondary prefix can be used only when carbon compound contains more than one functional group. This is what very important. So when a given carbon compound contains more than one functional group, when it contains more than one functional group, at that time we will use secondary prefix. Clear? We will use the secondary prefix. Here the secondary prefix also can be used apart from the more than functional group. Suppose example, I have given a compound here. You can observe here I have given a carbon compound, right? Here in this carbon compound I have given two functional groups. You can observe here I have given two functional groups. Clear? So I have given two functional groups. One is aldehyde, another one is alcohol. So if a carbon compound contains more than one functional group, at that time we can use secondary prefix. What is that secondary prefix? So in that functional groups we have to identify which is major and which is minor, so that we can observe according to the priority rule. Accordingly, priority rule. So as per the priority rule, we have to identify which is major functional group, which is minor functional group. Clear? So according to the priority order, we have to identify. So according to the priority rule, in next slide I will give you complete the priority rule order. So in that you can observe here aldehyde is the major deciding chemical property of the compound. So therefore this functional group will become major, and which does not decides the carbon compound chemical property, which does not decided by the OH, which is decided only by the aldehyde. Therefore aldehyde becomes major functional group and alcohol becomes minor functional group. So at that time, for major compounds, for major, which is major functional group, for those functional group you have to use secondary suffix. Which is minor functional group, for that you have to use secondary prefix. So once again, for every functional group we have secondary suffix as well as secondary prefix. Suppose example, once again I will repeat, for alcohol secondary suffix already have discussed, that is ol. Alcohol, last two letters I told you, right? Now the same functional group, if it is minor, when the carbon compound contains more than one functional group, in that if it is minor, then the secondary prefix will be used as hydroxy. What we will use as hydroxy term, we will use as secondary prefix. Like suppose example, in a carbon compound aldehyde became minor, so at that time we will use formyl term. We will use formyl term. So like that, there are some terminology is used to identify the minor functional group too. For the functional minor functional group, we will use the secondary prefixes. Like for alcohol, hydroxy we will use. For aldehyde, we will use formyl. For ketone, agar if it is ketone is the minor functional group, then for ketone we will write as oxo. Clear? So like that I will give you one chart for the priority rule based secondary prefixes. Clear? So once again I'm repeating, the secondary prefix is used when a given carbon compound contain more than one functional group. One will be the major, another one will be the minor. For a major functional group, we have to use secondary suffix as usually. Why? Because it is deciding chemical property. Another one which not decides, that will be minor functional group. For those type of compounds, we will use the terms separately, which is called secondary prefix. For alcohol, it will be ol. For aldehyde, it will be formyl. For ketone, it will be oxo. Clear? So in next slide, I will give you the complete secondary prefix chart with priority rule. Okay now.